Logarithms are a topic that always creates a lot of discomfort for students because we're not used to seeing a word represent a mathematical operation. But if you think about it, we kind of take for granted all sorts of random things representing particular operations in mathematics. Take, for example, multiplication. We originally learned that a little x in between two numbers means that we're supposed to multiply them. But eventually, we learned that x can represent a variable. So we can't use x as a multiplication symbol anymore because it gets confusing. So we instead say, if we put a dot in between those two numbers, that means we're multiplying. But don't put that dot too low because then that means 2.3 instead of 2 times 3. And then, of course, if we don't want to use a dot, we could use a set of parentheses around one of the numbers, or perhaps around both of the numbers, or maybe only around the first number but not the second number. And so all of these end up meaning multiplication. Now, if we put the two numbers next to each other with no dot, that means 23. If we put those two numbers next to each other, but one of them's a little bit higher, then that means 2 to the third power. Again, we only know all of these differences because of experience. What we don't have, to start off with anyway, is experience with words representing mathematical operations. Perhaps a little bit in geometry with sine and cosine and tangent being introduced there, but otherwise not much. So there's a couple things here. Number one, we want to remember that exponential functions and logarithmic functions are inverses of each other. So just like when you square something and you take the square root, those undo each other. If you multiply and divide by the same number, those undo each other. Add or subtract by the same number, those undo each other. Logarithms undo exponentials, and exponentials undo logarithms. So that's the first thing to keep in mind. And then a second thing to repeat as a mantra in our head is that a logarithm is an exponent. What do we mean by that? Well, if we take a look at the pattern of how we can rewrite an exponential in logarithm form, we can see that the exponent of the exponential becomes isolated and is equal to a logarithm. So the base b of my exponential becomes the base b in my logarithm. The answer, or the output of my exponential y, becomes the input into my logarithm. Here we're getting that inverse idea of inputs and outputs flip-flopping. And then finally, my exponent, my input into the exponential, becomes the output, or what my logarithm equals, in a logarithm. And then we have these other conditions here where b, the base, has to be a positive number, just like it has to be with exponentials. The base can't be 1, and what we input into a logarithm can't be negative because the output of an exponential can't be negative. And since logarithms and exponentials are inverses of each other, if you can't have a negative output from an exponential, then you can't have a negative input into a logarithm. All of these things we'll explore in greater detail later. For now, all we want to do is be able to rewrite, so I'm going to kind of clear some space here. We just want to use this pattern to rewrite exponentials as logarithms and logarithms as exponentials. So if we look at this first one, we've got 5 to the third equals 125. So I want to use this pattern here to rewrite each of these exponentials as logarithms. So the base of my exponential is going to become the base of my logarithm. So I'm going to start off and I'm going to have log base 5. Then the output of my exponential, y, becomes the input into my logarithm. So I'm going to have log base 5 of 125, so there's my input. And then because we said a logarithm is an exponent, the exponent here is 3, so therefore log base 5 of 125 equals 3. So we're just using the pattern there to rewrite each of these exponentials as a logarithm. For the second example, we've got a base of 9 on our exponential, so that's going to become the base of my logarithm. So we're going to have log base 9. Then the output of my exponential, y, becomes the input into my logarithm. So that's 1 over 81. And then because a logarithm is an exponent, my logarithm is going to equal the exponent here. So it's going to equal -2. For the next couple of examples, again, our base is 4 for our exponential. So that's going to become the base of my logarithm. The output of my logarithm y becomes the input into, or the output of my exponential becomes the input into my logarithm. So that's 24 is going to be the input, and then a logarithm is an exponent. So my exponent in this case is x, so my exponent becomes the answer to my logarithm. Log base 4 of 24 in this case equals x. For the last one, so now we've got base 16 on our exponential, so base 16 on our logarithm. The exponential output is 64, so the input into the logarithm will be 64. And then a logarithm is an exponent, so my exponent becomes what my logarithm equals, so 3/2. So all we're doing is we're just following the pattern of what we see here, and just the b of the base of the exponential becomes the base of my logarithm. My exponent becomes what my logarithm equals. What my exponential equals becomes the input into my logarithm. So here now we're working in the opposite direction. Now we're given a logarithm and we want to rewrite it as an exponential. So we can refer to what we have at the top of our notes, but the idea here is our base of our logarithm becomes the base of my exponential. So 2 is my base. A logarithm is an exponent. So whatever my logarithm equals, that's going to be my exponent. So it's going to be 2 to the 4th equals, and then whatever was the input into my logarithm is going to be the output of my exponential. And so 2 to the 4th is 16. In the second example, we've got base of our logarithm is 5, so the base of our exponential is going to be 5. A logarithm is an exponent, so that means whatever our logarithm equals becomes the exponent on that base, and then that's going to be equal to the output for the exponential, which is the input of the logarithm, 1/25. Moving to the next row, 49 is the base of our logarithm, 49 is the base of our exponential. A logarithm is an exponent, so whatever our logarithm equals becomes the exponent in our exponential, and then whatever the input into the logarithm is becomes the output of our exponential. 49 to the 1/2 equals 7. And so to close things out, 9 is the base of the logarithm, 9 is the base of my exponential. A logarithm is an exponent, so that means my exponent is going to be 3/2, and then that's going to be equal to the input into the logarithm, which in this case is x. So all we're doing is we're just following the pattern at the top of the notes to rewrite each exponential as a logarithm or each logarithm as an exponential. It's important that we get this down so that when we're faced with more complicated questions involving logarithms and exponentials, we can at least rewrite each in the opposite format, as will be necessary quite often.